All right, we can start. Okay, so welcome to our next session on 5G and IoT. Uh, can people settle down? We can give 30 more seconds for people to finish their chit chat. We don't want to disrupt any chit chat. So while we are waiting to get our session officially started, a lot of friends of mine in various disciplines ask me in social setting, when we are having adda. Adda is a term that I can use in India and everybody will understand. In the rest of the world, if I say adda, they'll say, what is this guy talking about? So you know what is adda. So when I'm having adda, and they know that I work in this networking field, they ask me, hey, what is 5G? I say 5G, that's simple. Gandhiji, Nehruji, Mukherjee, Banerjee, Chatterjee. But of course, then we have to get serious. And so let's get serious. Okay, so without further ado, let me get started. So in today's plenary session on 5G and IoT, we have, besides myself, Professor Bhavani Sinha from ISI Kolkata, and Dr. Rishi Bhatnagar, who has his own company. And we have another person who is not here yet. I don't know if he will be coming, but we will get going with our speeches. So good afternoon, everybody. Just like I did with the previous session on cloud computing virtualization, I tried to give a very general overview of what these terms meant. And again, noting that we have an audience with very diverse knowledge and expertise, many students who would like to learn what these terms mean and perhaps take up research in these topics, as well as many colleagues who are senior scientists, but they hear about these terms. What do they really mean? So that is what I'm going to cover today. So very, very high level tutorial-oriented material. And my other colleagues on the panel will get into a lot more exciting details. Just like it happened in the previous session, I was delighted that they were able to impart a lot of additional knowledge beyond the simple stuff that I spoke about. All right, so my name is Biswanath Mukherjee. I'm a professor at University of California, Davis, where I've been there for 30 years. I did my PhD from University of Washington, and before that, I was a student at IIT Kharagpur. But I come to India very often. Maybe I should come more often. I have a job here to do right now, so let me try my best. So what is 5G? 5G is the fifth generation, okay? So we have first generation, second generation, third generation. Initially, we start off with only voice, and then we have data, but really, really elementary technologies, and data rates weren't very good. And then the technologies improved and the data rates improved. But now we are talking about really, really massive amounts of data where we want to have the wireless or cellular connectivity, but we don't want to be connected by wire. So here we have to keep in mind that the optical fiber, and in Andhra Pradesh, we heard from the Chief Minister, they are putting optical fiber everywhere. The optical fiber has huge capacity, but we don't want to be connected to fiber. We want to be untethered, right? So can we bring fiber close to people? And the last few inches, perhaps, is wireless, okay? So in the past, optical access networking that people have been developing, and there's fiber to the home and fiber to the business. And then the cellular and wireless, they've been working out of sync. Now we need a more integrated approach, okay? And I'll try to touch on that a little bit as to how that might work in case of the 5G, emerging 5G networking architecture and thought process. So the requirements that people are starting off with is we need 1,000 times more mobile data volumes that need to be handled, 10 to 100 times more connected devices, 1,000 times end user data rates, reduce the latency by 10 times, mobility increase, that is, people might be moving faster, high-speed trains, et cetera, 50%, extended battery life 10 times, lower energy consumption 1,000 times. And when you look at these requirements, you must be asking, are you kidding? How can all this be done? But there are few opportunities that are there for us to exploit. And so we refer to them as the big 3 5G technologies. One of them is ultra densification, okay? So, what is the coverage of a cell site, okay? Within this cell area, we cannot have frequency reuse, but in other cells, okay, that are a little far away, we can have frequency reuse. So if we shrink the size of a cell, we can have more opportunities for free spectrum reuse. But then we might have too many cells and too much equipment to handle, and that can be very difficult to deploy, and the capital expense and operational expense and energy, and we can't put cell stuff everywhere, right? So there are real estate issues and so on. Then there's so-called massive MIMO, multiple input, multiple output. And this is a little loaded term, and maybe some of this will be covered by, what is the outcome of this is what I'm going to show, okay, when we get to this. This is a pretty advanced topic, actually, okay, and there can be a full extended talk on this topic itself. And there are some parts of spectrum that can potentially be exploited better, okay, and so on. So here is some illustration of what we mean by densification. You can see that the cell sizes are shrinking as we get up in the technology generations. And so we have more active nodes, smaller and more concentrated coverage of base stations, which can enable us to have better spectrum reuse, reduce resource contention. But the challenges are how do we establish seamless communication, especially if we have high mobility, and this can actually lead to high cost for both capital and operational expenses. So one possibility is this cloud radio access network. So radio access network is the network of base stations, and from base stations, the connectivity to the various points of presence from where we have access to the rest of the network, be it voice or data. Cloud radio access network has some aspects of cloud that we just talked about before, which really means, what we are showing here on the bottom left is present mode of operation. At each of these base stations, you can see, okay, we don't have a pointer here, right, do we? Yeah. But on the screen, it might not work, right? Yeah, the screen will not work. Okay, let me see if I can work with my cursor here. Well, doesn't work. Anyway, at each of these base stations, you can see DU-RU written next to them, right? So DU stands for digital unit, RU stands for radio unit. So each of these base stations needs a radio unit, but the digital unit is really like the computing part, okay? And, I can actually not need to have the computing information over there. I can actually pool the computing information up to this DU pooling that you see on the right. So now each of these cells only have RU. So I have essentially shrunk my hardware quite a lot. So it is very lightweight hardware, only for the radio communication purposes. And now we have this DU in the cloud, and the connectivity between the RU and the DU can be provided by fiber. So now we call it the front haul network. Okay, so the front haul provides connectivity between RU and DU, and beyond the DU, we can have backhaul, which connects to, which is the regular backhaul that we have today. Okay, so what are some of the advantages of this kind of architecture? Well, in some cells, maybe sometimes there's a lot of traffic, sometimes there's not much traffic. Okay, we can actually pool many of the DUs together to serve a large number of RUs. Therefore, we can have energy efficiency. Also, if we have many small cells and each of them have RUs, but they have a common DU, and if you are moving very fast through these RUs, okay, you have the same common DU. So handover issues can be well managed. Okay, so mobility can be better managed, energy efficiency can be well done. So we have essentially, therefore, a concept of a virtual base station where many RUs are served by the same DU, and if you are moving around in them, only RU to RU handover is needed, and the DU handover is automatically taken care of because of the way the architecture is. Okay, so this is just some elementary version of what DU pooling really means. Okay, people also call it bandwidth, a carrier hotel, or a BBU hotel, baseband unit hotel, and all that. Okay, so those are additional terms that people use. Okay, so we have the DU cloud where we have the computing resources. We have the front haul, which can be the optical network, which has high bandwidth, and then we have the radio access resources. So in case of the optical network, we have what we call ONU, Optical Network Unit, okay, where which provides connectivity to the DU cloud through this OLT, is the optical line terminal. So this is our standard broadband optical access network. So the optical fiber network that the Chief Minister was talking about the other day, just yesterday, I think, or day before, that is essentially this type of network. So it is a broadcast type network. There's an OLT, optical line terminal at the head end, and there are various ONUs, optical network units, which could be deployed in people's homes or in the curbside, in the neighborhoods from where we can have copper drops to people's homes, essentially bring high capacity as close to the end user as possible. Okay, and millimeter wave means repurposing existing millimeter wave spectrum for mobile cellular communications to achieve a high throughput and in small areas. And then we can have directional beamforming. So what this really means is, most antennas are omnidirectional. Okay, that means if you have a base station, it is sending out signals with equal power in all directions. We have sectored antennas as well, sectored base, where maybe there are 3 of these antennas that are serving 3 base stations, but each of them have maybe 180-degree sectors. But the directional antennas are ones where you can actually have more focused beamforming towards where your users are. As a result, we are not wasting power by transmitting in all possible directions. This way we can have better spectrum reuse. We are going to reduce collisions, and we can have more users that can be supported. Of course, there are other issues about power and health and all that, which I don't understand, but I think it's important for somebody to address those kind of issues as well. Okay, about Internet of Things, I will not take much time except show a slide here. So at the bottom left, we have what we call things that can be put on the internet. Your toaster, or actually today we do have a lot of the energy saving stuff, right? Turn on the air conditioner or heater, before you get home, and fridge, control the temperature, or the security cameras and so on, right? But then, are they architected properly? You can put them on the internet. So what kind of, networking architectures and system architectures and services, okay, need to be further developed? Because it is expected that we'll have like 50 billion things on the internet by 2020. And I think Dr. Bhatnagar will cover some of these things as well, okay? Okay, so I will not take much time then, because I would rather have Professor Sinha and Dr. Bhatnagar spend time on their expertise on these things. I should just add one other thing. You know, in the previous session, we talked about cloud, okay? And so the cloud is, you know, up there, but now there's also the concept of fog. So cloud computing, fog computing is, you know, not so much up there, but a little closer to you, where maybe some of the information that is important for local consumption can be closer, so to the consumers, or maybe replicated closer to the consumers, so that we can reduce latency and therefore also balance load all across the internet. Okay, so this is fog computing that is also you know, coming up as a big thing. Okay, so without further ado, let me just stop here and you know, see if there are any general questions that people might have, and then we'll get to our other speakers. Okay, thank you very much.